So we are starting with our title of the workshop is Data Science from Choice to Necessity. Table of content in this workshop, talking about data science. So what exactly is data science? What is the major difference among the terms data science, artificial intelligence, machine learning and deep learning? Next is data science life cycle. After that, we will be talking about data science applications, prerequisites to learn data science. If you want to learn data science, what exactly you require? If you want to become data scientist, what skills you need to learn? Job roles in data science and why you should be becoming data scientist. And after that, we will be learning about basic skills to be data science use cases we are going to discuss, and career outlook in this domain. Learning objectives of this workshop. In this course, you will be learn about the process of data science, how actually data science is boosting the businesses, or does it actually require in all the domains or all in the businesses? Let's see that. Achieving business excellence through data science. Why data science is important for everyone. Okay, so first we learn what is data science. Anyone can give me a random guess on that. What exactly is data science? You can write in the chat box. What is data science? So let's talk about the exact terms now. Data science is a field of study that deals with large amounts of data. So whenever we are doing some kind of analysis, so this we are doing with a large amount of data by using modern tools and procedures to discover unseen patterns, and after that creating useful data and making business decisions. So if I talk in a simple terms, what is data science? With the help of data science, we can actually predict the future. Now what is the future? Now I can take an example that one organization is having profit of maybe 20% of the profit they are making in the year 2022. Now, what will be the profit in year 2023? So how they can how they can make this decision based on the data, and for that they need a large amount of data. And on top of that, they are applying some modern tools and procedures and then discovering the pattern, the information on that, and then creating the business decisions. So what we understood for now, data science is dealing with large amount of data, applying some tools on that, applying some algorithms on that, that is maybe machine learning algorithm, or some maybe we can say some basic probability algorithm, and after that getting the results, and based on that result we are making the decisions. So we will take some other examples as well, then we will be able to understand it fully. To create predictive models means to create the prediction, data scientists use complex machine algorithm, and that machine algorithms we will learn about what is machine learning as well. Data for analysis can come from variety of sources and be presented in a variety of formats. Now, it is not necessary that you will be dealing with the data from an Excel file only. It's not necessary you will be dealing a data from only a text file. That can be n number of files with us and n number of formats as well. Now, what is the format? We can take an example of an organization that is working worldwide. So if they are recording their data, in that recording of the data, what is happening here? In that record, UK's time is different and India's time is different. Canada's time different, and they have all the countries are working in the different time zones. And whatever data they are fetching, so they are fetching in their own time or on date or time. But when we are doing the analysis on something, what we actually require the same kind of a format. Similarly, I can take one more example. We are storing the name of the customer. And in that storing of the customer in one format, first name and last name is in two different columns. And in the next data set, what we have the full name only. We don't have first name and last name as in a different manner or as in a separate columns. So whenever we are making that analysis, we need the data in a proper format. In fact, we can say the uniform format only. So that is why only then analysis is possible. Data is new oil. So before 5 years, in fact, I'll say before 3 years, the oil-based countries they are having oil, they are considered as the richest. And now what happens? Now what we can say, the country who is having more informative data, that are the richest one. So data is the new oil, but you need to know how you can use that. All the countries are moving to industry 4.0. So what is industry 4.0? Anyone want to answer on that? You can write in the chat box. What is industry 4.0? So industry 4.0 is the target industry where everything will be digitalized, where IoT sensors will be used. IoT sensors are Internet of Things. So these sensors are going to monitor everything. They're applying artificial intelligence on that AI generation Ankit mentioned there. So industry 4.0 is targeting everything should be online, everything should be on internet, everything should be on a trackable basis. And for that, what we need a data. So if we need the data, that is why data is a new oil over there. We have the data now. How to get the data? First, we need the data. So this is the process we are seeing. I'll write some things as well. I have opened Microsoft Word here. So now let's understand the data science first. So we will not go to the definitions. We will not go to the bookish terms. We will understand what is data science. So data science, they mentioned that. So it works with a large data. So we have large data. Now in that, from large data, what we need to do? So this is our input in that case. This is our input. In data science, what we are doing, we need to analyze on that. What output we need? What kind of output is required here? Output is the future prediction. And this prediction can be about anything. You want to know about the profit, you want to know about the customer's behavior, you want to know about the policy making. This future prediction can be anything. So to achieve this output, what we are applying on that large data? We are applying machine learning algorithm. What is machine learning algorithm? That we will understand. We are applying machine learning algorithms over there, and based on that, what we are getting? We are getting useful data that is actually required. And based on that, based on this useful data, what we are making? We are making decisions. So that decisions can be related to any business, whether it is a customer business, where it is a service-based business, where it is a product-based business. So that is why data science is required everywhere. So this is the process of the data science. Okay, I'll move further. Next process is extraction of knowledge. Now see, first part, how we can get. Now what we are talking about? We are talking about this useful data. How we got this useful data? How we got this knowledge? So this is the main thing here in the data science, because that is required to make the decisions in the businesses. So for that, what we will do, useful data, to get that extraction of knowledge, first we should have the data first. Now, data collection. So now think about what are the sources of the data collection, from where we can get the data. So I'll say that in my organization, we already feed data. So this is the data provided by organization. So in fact, we can have the customers data from manual form filling. This is another source. Or we can have feedback from different people. This we are getting. We can do web scraping. Okay, what is web scraping? This is unwanted thing. No, Mahesh, this is wrong. review, no. Web scraping. Web scraping, web hosting of web data extraction is data scraping used for extracting data from websites. Yes, Ankit, that's correct. Obtain large amount of data. Now, I'll take an example. In LinkedIn, what we do, in LinkedIn, I'll save my name, I'll save my basic information, my city and all that. After that, I'll write about my qualification, what I have done. I have done 10, 12, my graduation, post-graduation, PhD. After that, I'll be writing about my job, my experience as assistant professor, my certification, my projects, all things I can mention that. So if I talk about the web scraping, through web scraping, what we can do, we can save, we can store all that data into a Excel file. Similarly, we have Facebook, we have Instagram, we have other social platforms. There we have the data in the text format. So we can save that data in our format, maybe in the Excel or in the text file or in a JSON format. So this is web scraping. So basically getting data from the web. This is web scraping. So, or we can, in easy language, we can say the extraction from the internet. So these all are the sources from where we are collecting the data, or maybe any organization, they are having their own software. So they are getting the data from that software. So that is why in the previous slide, it was mentioned that the sources of the data can be different. It can be from any source, but whenever we are doing the analysis, we need to make it in the same format. So we have multiple sources of the data collection. I'll move further. What is the next step? So once we have the data, what we are trying to do, we're trying to fetching the knowledge from the data and from using the data science. So the next step will be data cleaning. Now, after getting the data, I have the data now. After getting the data, I need to pre-process the data, and that is known as data cleaning. So what exactly we do in the data cleaning? The first thing we do, we make a uniform format. Uniform format. So we were talking about like one format is having first name plus last name in a single column, and another format is having first name and the last name in a different column. So I need to make a same kind of format over here. I need to do some processing on that. I need to make a date kind of thing, date, time, all this I need to make in a same format over there. I need to do some conversions here, there. One more example we can take. We have a salary column. In that salary column, some of them are recording the records in the Indian rupees, some are recording in the USD, and some are recording in the some other currency, maybe the pound. So this, whenever we are doing this, so that time what we should have a same kind of figure. We need to do the conversions. What I can do, maybe I can convert everything in the USD, or maybe I can convert everything in the INR to do the analysis. Similarly, maybe we have one column over there. In that column, we are having some kind of GST, or we are having some kind of interest, or we are having some taxes. So we can see in India, maybe the taxes GST. In the country USA, we have a different text. So I'll write a different text here. So that time also we need to make a uniform conversion in the data. Only then we are able to analyze the data. We can't go like that. One salary is in the Indian rupees, one salary is the USD, and if we are doing the analysis in a same kind of format without changing anything, at that time we will be getting the false results. That is why we need to make data in the uniform format. So this is the first thing that we do with the data cleaning. After that, what we do, then we do cleaning. What can do? The main thing is looking for outliers. Outliers in data science is very important term. In many interviews, recruiter easily ask what is outliers and what are the methods that we use to remove the outliers. So this is very important when if you are targeting this profile, data analyst, data scientist, data engineer, read about outliers. It is very important topic, and what are the methods that we use for removing outliers. So what is outlier? Now I'll see that I have a age column, or maybe I have a salary column. Now just think, we will be considering very simple examples so that we can understand. So this workshop is basically targeting to clear your all basics related to data analysis. So we want to have a strong hands-on or strong foundation on the basics of all the terms. So let's take a very simple example. I have a field age here, and what I'm targeting, I have the employees from maybe 25 years to 55 years. So this data set we have. Suddenly, what we have, such values, some of the values are having the age as 109. Some columns are having the age as maybe 450. So this is obviously at error only. Similarly, for the salary, maybe most of the people are taking from 25,000 INR to 1 lakh INR. But suddenly for few people, what I see a salary in 1 crore, or I see a salary in a 10 crore. So now see what you are doing. You are just directly doing the analysis on that, and what you are calculating, you are calculating average of age, you are calculating average of salary, then you are calculating median on that, or any other value you are calculating for doing the data summary. You are having this kind of results. Now because of these values, that is 109 or 450, because of the values that is from 1 lakh, or I'll say from 1 crore to 10 crore, the complete result of your data will be wrong. Your average will be wrong because of such values. So this is why, that is why it is necessary to remove the outliers. Now just think about that. You have millions of records in a data. You're not only dealing with some 10,000 rows, you are dealing with multiple rows, because you are dealing with the large data only. This is the basics of the data science. So in that case, you cannot go through the single row over there, and then we come up with some maths magic. We use some maths there, and then we can actually remove the outliers. So this process, this looking for outliers and removing that, this comes into the data cleaning part. So what we have done, we have make the uniform format, we have make the looking for the outliers, and then we are removing them. Third thing we do, what we do in the data cleaning, we deal with the missing values. What is the missing values now? So similarly, for maybe I have a record of, I'll say, I'll take only 10K rows in example. I have a record of 10,000 employees in my data. From that 10,000, what I have, for 1,000 people, I do not have the salary information. I do not have the salary information. So this is my missing value. I'll say it as a missing value. So 1,000 people are not, I don't have any detail on that. But when I'm making the analysis, now I need to see, I can have the salary for detail for these 1,000 people. If I don't have, what I need to do, maybe one case can be from that 10,000, what we can, whatever analysis we are making, we will consider only the 9,000 people. We will not be considering the 10,000 people. One alternative. Second alternative, maybe I can calculate average for the 9,000 people, and for 1,000 people I can save that value. I'll say maybe for the average value for the 9,000 employee, my average is 25,000. So I'll replace these missing values with 25K when I'm doing the analysis. So this we need to decide, and this decision is entirely dependent on the data and the analysis, or what kind of output you want from the data. So in the data cleaning, we do majorly three things. We make the uniform format of the data. We look for the outliers and remove that, and then we decide what to do with the missing value. This is the dealing with the missing value. So this we do in the data cleaning part. What is the next step in the extraction of knowledge? The next step is problem formulation. Now, what is problem formulation? This is setting your objective, setting your goals over there. What are the goals over here? Now, I'll take an example that we want to have a profit. So profit case we were considering there. So let me take an example that in year I want to have the future prediction on the profit for the year 2023. Now for the year 23, what I have in the record. So I have the record for maybe from 2030. I have record for 2040, 2015, I'll say 2016, 2017, 2018, 2019, and 2020. 2021, I have the results, and 2022. So I have the profit information available for all those years. Now, maybe what I want to calculate, I want to predict the profit for my company. I'll see here my cost over here, my products cost I have. So all these values I have about my business. What I need to do, this is my target value. So whatever you want to do with that data, that should be formulated over here. So you will specifically write what is the goal, what is the problem, what you want to do with the data analysis. What I want to do, I want to predict profit of, maybe I'll say of ABC Private Limited in year 2023. So these goals should be clear about that. Now, if I'm dealing with only 2023, so I'm not talking about 2024, I'm not talking about 2022 or any other year. So this is my problem formulation part. So whatever you want to do with that data science quotient, that should be clear to you. That is the step of the problem formulation. So we have the data collection with us, we have the data cleaning part, and then we have the data problem formulation over there. So once we have the data, we will clean that data, and then we will decide what to do with that data. So this is next come magic with the modeling. Now, by now, every one of us have heard about machine learning can do this, machine learning can do that. So whatever we are doing with that on that data, that we do with this kind of modeling, and that is machine learning. In that machine learning, now understood it carefully how machine learning do this. So what we will do now, by now we have the data. Now data we can understand this, we have this year data with us. As now in this year, maybe I'll say in 13 I have 5% profit. So I'll just take a random values. Then I have 4%. After that it is 10%. Let's take it 11%. And then I have maybe 13% here. Then in 18 it got down as 9%. Then we have 11% again. We have 30. I'll say in 2020 it increased suddenly as 30%. And after that, again in 21 it is 30%. So this kind of data is available with me, and even for 22 I'll take 31%. So now what we want to make sure, we want to calculate it for 2023. Now understand it carefully what machine learning will do. I have the data with me, data collection is done, data cleaning is done, my goal is decided, this is my goal. So I have the clean data and everything. What I'll do first, in machine learning, what happens, machine learning is having some kind of algorithms with that. Based on that data, the first step is to decide the ML algorithm, like which algorithm will be suitable for your kind of data. And believe you in me, the first step is very important in the machine learning to decide the machine learning algorithm. If any machine learning is not working fine, the reason behind is that we have chosen the wrong algorithm. And how we can got it to know that if we are choosing the right algorithm or wrong algorithm, this we can understood by the accuracy. And based on the data, we have different algorithms and that is suitable for same kind of a data. Like we can say for the image kind of data, we have different algorithms. For the text-based data, where we have natural language processing things to do, applications to do, that time we have different algorithms. So based on that data, we can decide what kind of algorithm will work on that. So once our algorithm is decided, what we'll do, we will train the data, train the machine learning model. How we can do that? Now understood this training, how we can do. So maybe I have how many years data with me? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 years data I have. So what I'll do, I'll use the 6 years data as for the training my model. Training the model, like how I am training that, I am providing input as well. Like this is my year. In this year, this was the production cost, this was the revenue, this was the that, this policies we did, whatever solution or whatever inputs I have, that I'll provide to this machine learning model. And based on that, what kind output I got. In this way, I'm training the machine learning model. I'm telling the input as well. I'm telling the output as well. So once I'm done with the training of the model, then I'll test my model. How I'll test the model? Testing the model. How I'll test? I'll again give the data of next 3 years, that is for my 2019, 2020, and 21. I'll provide the data. I'll give the input. Again, I'll give the input, and then I'll expect from the machine learning model that this machine learning model will be giving me the output. And based on that output, I can actually calculate the accuracy of my machine learning model. That is why if you have heard about my machine learning model is giving 87% accuracy, my machine learning model is giving 89% accuracy or 90% accuracy. So that depends on the accuracy of the machine learning model. If anyone of you have seen the Shark Tank's episode, Shark Tank India, there also many startup came up with the artificial intelligence based on machine learning based solutions. So over there, their first question was that what is the accuracy of their algorithm. So based on that algorithm, the person can decide how better this algorithm is dealing with. So now if the accuracy of the machine learning model is good to go, then what we can do, we can actually finalize the model and we can get the result for finalize the model. The model is finalized, then we will calculate, we will again give the input. This time input is for the future, and that future is 2023, and then we will be getting the output from our machine learning model, and we will be getting the results. So this is our way how we can do. First, deciding the machine algorithm, then training the machine learning model from the input and the output. That time we are providing input as well output to the machine learning model. After that, we are testing it by only providing input, then expecting that machine learning model will be returning us the output, checking the accuracy. If this accuracy is not fine, what to do? You need to change the machine learning model and do this process again. If only then if your accuracy is finalized, then you will go for the modeling and get the results. So once you have the results, you have done the magic with the modeling. That is the fourth step: data collection, data cleaning, problem formulation, and then magic with the modeling. Now if you have the result, visualizations of the results is necessary. Now you are working as a data analyst or data scientist. Your company's manager asked you to present the profit for the 2023. Now you have got the results. So you will not tell the results in a numbers. You will not tell it like sir, you will be getting 33% profit in the future. No, this is the wrong way. What you need to do, you need to present your data, you need to present your output, not in the numbers, you need to present it in the graphs. You need to present it in the different kind of visualization. Maybe you can use the pie chart, or you can use any other graphical way to present your data. That is the correct way to present your data over there. Not in the numbers, you need to go with the dealing of the data. So now that graphs you can make in maybe Excel. That is why the companies in the data scientist profile, they ask about the Microsoft Excel. You can go with the tools like Power BI. You can go with the Tableau to make the graphs, or maybe you can use any other tool to consider the values here over for visualizations of the results. So that is why all these tools are being asked in the data analyst profile. So this is the process of extraction of knowledge. Now we have understood the data science fully. Data collection, we know about data cleaning, we know about formulation, problem formulation, we know about the machine learning also now, and visualization of the results. But what is the difference between or among all these terms? We have lot understood or heard about data science. We have heard about the artificial intelligence, machine learning, deep learning. How these terms are related? Let's talk about that. So this you can understand. This is artificial intelligence. This is machine learning, and subset of that is deep learning. Now let's come to some definitions. The term artificial intelligence refers to the ability of a computer to mimic the human behavior in a some way. So if a machine is targeting to mimic the human behavior, so that is artificial intelligence. Now the term artificial intelligence, it is referring ability of a computer so that it can actually behave like a, you will be having a confusion, we are dealing with a machine or we are dealing with a human. So that kind of formation or that kind of loophole, or we can say the presentation is artificial intelligence. Next, data science. Data science is basically subset of artificial intelligence, where what we do the some kind of a future prediction, and there we use the fields, we use statistics there, we use scientific procedure, that is basically machine learning, we use the data analysis, and using all these, what we are using, statistics, scientific procedures and analysis, and what we are getting the meaningful information on that data. So this is data science. So this we can say it is already a part of data science only. But what is machine learning? Machine learning is a subfield of artificial intelligence that includes techniques that allow computers to figure things out from data and deliver AI applications. So in machine learning, we actually have some kind of algorithms over there. Even new algorithms are into research and development phase. And based on that algorithm, what we can do, we can make AI applications. So in easy language, I'll say machine learning is a tool to deliver the application that is artificial based application. And for good measure, we will throw in another definition, that is deep learning is a type of machine learning that allows computers to solve complex problems. So machine learning is the basics. So once we are moving a step ahead, when we are having more complex things to do, like we have some image classification, we have some image extraction, we want to deal with only image based data, or I want to deal with the recording of the cameras, CCTV cameras. So those algorithms require deep learning algorithms. So we have a different category where what we are doing, we not only talking about the basic terms, we are talking about the advanced terms as well. For that, we have the algorithm that only deal with the complex algorithm, that is data deep learning. So we have understood artificial intelligence is the hierarchical top hierarchy, and data science is the application. So for using or having the data science, we can use anything. We can use artificial intelligence, we can use machine learning, we can use deep learning. And artificial intelligence is the super category, machine learning comes into that, and deep learning is the advanced one. These are the basic difference among those terms. Now, how data science life cycle works. Now, you consider yourself as a data scientist. So in that life cycle, what you will be doing? You will be capturing the data first. Data collection we need to do. So data capturing. Now, who do the data capturing? Who collect the data? You're working as a data scientist in a company. Who is going to collect that data? Just think about that. If anyone is having answer on that, write in the chat box. According to you, who is going to collect the data? What happens if I'm working in a very small company, I got the position as data scientist. In that case, maybe I'm the responsible person who is collecting the data. But if I'm working in a product based company or in a large company, in that case we have different people who collects the data. It can be any executives as well. So even the analyst will not do that, even data analyst will not do that. But in some of the companies, so it depends on the size of the company. Every organization has having different culture over there. Maybe somebody else is providing us data. This is data collection, but sometimes data scientists also need to do that, and data analyst as well. Next step, maintain the data. Now, this maintenance can be data pre-processing or storing the data. We talked about the web scraping. So web scraping is not only one-time procedure. If we have done the web scraping, we have got the data from the internet. After that, if we want to use that data somewhere, we need to store that data. So that data we need to maintain. For that reason, we have the data engineers. Data engineer, they only deal with the data. And again, if the company size is very small, data scientist or data analyst, anyone has to do that. That is maintenance of that data. Next, process the data. Data processing is like, it can be applying the rules or applying or pre-processing, cleaning the data, making the uniform data. That whole process is necessary there. Now, this part is only data analyst or data scientist can do. This processing part, only data analyst or data scientist can do. Then we have the analyze the data. Again, data analyst can do, data scientist can do this part. Then we have the communicate the data. If we are applying basics algorithm over there, data analyst is able to do that. If we are applying complex algorithms, only data scientist will be able to do that. Communication is basically visualization of the results, but who the person who is presenting that result, he or she should be able to deal with the client as well. For example, I'm working in a company that only deal with the data science projects, and the client is from a telecommunication sector. So once I have the results, I need to present that result to my client as well. So that person should be able to communicate well with the client. It should not look like that you worked hard on your project, but you cannot present your work in a very good manner. So that will be lack of our company. In that case, the communication is very much necessary. The presentation of the results are very much necessary. So this communication is also an important part in data science lifecycle. So we can capture the data, we can maintain the data, we can process the data, analyze the data, and the communication of the data. In small company, only a single person or a single team will be responsible of doing that. In a large company, obviously they will be dealing with large projects only. So we can have different people over there for data collection. To maintain the data, we can have data engineer. Processing and analysis, we can have data analyst or data scientist as well. And for the communication, we can have the business analyst or we can have the data analyst. They can present their work well to the clients, or maybe data scientists also can do that part. Capture comes, what it can have, it can have data acquisition, it can have data entry, like somebody is entering that data, signal reception, and the data extraction. What is signal reception? Signals, you can take example of sensors data, signal reception. What is sensor? Anyone can answer on me that? Sensors, we can have temperature sensor, humidity sensor, or we can have a location sensor. what we can have, what kind of information we can have the sensors. We can accumulate the data in form of digital systems such as IoT devices and control systems. What is signal reception? So signal reception is basically we have deployed sensors on a particular field, and these sensors are giving us back the data in the form of the signals. So this is also one type of a data collection. Example of data extraction, we can take web scraping, acquisition, getting the data from any other resource, like from a third party, data entry, somebody from our company is only collecting or entering the data. Now, this stage entails gathering raw, unstructured, and structured data. So whatever data we are acquiring there from the entries or from any other source or from the sensors or the web scraping, this can be in any form. It can be raw data, it can be not structured one, it is unstructured data. So in that case, we have different categories of the data. Next comes maintenance, where we can maintain the data. We can store our data in data warehouse. We can clean the data. We can divide our data in different stages. Like this data I required at the first stage, second stage, third stage. So staging we can do. We can process the data by doing the conversions over there. We can make an architecture of the data. Like we are storing our data in a large server, and we are putting some kind of access there that only a useful or only the related people can access the data. So this is the process of data architecture. This stage entails taking the raw data and converting into a usable format. So in the capture lifecycle process, we have unstructured data, but if we are in the maintain state, that time we are making a usable format that is required. Now consider a example that I have a timestamp as well in my data. I have some status of the marital status of the customer. I have some other kind of information about the customer, but that information I actually don't require in the analysis process. So what I'll do, I'll remove that data. I'll keep only the required data that is relevant for the data analysis or data science process in the maintenance part. Let's move for the process. In the process, what we do, we mine the data, we get the useful information over there. We do the clustering and the classification. These are the terms that are associated with the statistics. Then we do the data modeling. This is related to machine learning. And then we summarize our data. Data scientists assess the produced data for patterns, ranges, and biases to see if it will be useful in predictive analysis. So this processing happens over here. Analyze, we do exploratory, confirmatory analysis on the data. That depends on the data, what kind of analysis is required over there. Predictive analysis we do there. Regression we perform. This is also one of the technique. Text mining we do. Qualitative analysis. So these are different types. And it is not necessary that we will be using all the types over there in the analyze part. We can be using any single type. We can be using any multiple type, 2 or 3 combination we can use over there. And this is the main part of the life cycle where we actually get the useful data, analyze. Here we get the output. Input we provided, here we get the output. This stage involves performing the various analysis on the data to get the useful results over there. Then we have the communicate. In the communicate life cycle, what we do reporting, data reporting we do data visualization, we make use of business intelligence, and then ultimately we take the decisions on the company. In this final step, analysts prepare the analysis in clearly legible forms like charts, graphs, or reports. We don't display the numbers over there. We display charts, we display graphs, we represent the reports like we have the reporting system in the Power BI or Tableau dashboard we can use. So this is all about data science life cycle. Then we will move to the applications of the data science.